Hello, this video is going to take a look at Chapter 19, Objective 7, where we go over the cardiac cycle. So I encourage you all to take a look at these cardiac cycle notes that you have in your packet, because we're going to go through those. So I'm going to go ahead and use the 7-phase cardiac cycle. There are some people that use the 5-phase cardiac cycle. It honestly doesn't matter. It's all, you're still learning all the same information. It's just how are you breaking up that information. I like the 7 phases. It just makes more sense to me. So you do have the handout, so I encourage y'all to go take a look in the packet and go ahead and get that out, because you're going to need to know for each of these phases, for example, you're going to need to know the name. Now, I'm not going to ask you, for instance, phase 2, what's its name? I'm not going to ask that. I'm not going to give you any of the numbers of the phases. I just need you to know what happens in the order that it happens in. So I've named the different stages. Atrial, I haven't named them, I got them out of the textbook, but we're going to use these names. Atrial contraction, isovolumetric contraction, rapid ejection, reduced ejection. So sometimes people combine these two phases right here, the ejection phase. I've got it into, I like it better when it goes through rapid ejection first and then reduced ejection. Isovolumetric relaxation. And then again, sometimes people combine these two phases, the rapid filling versus the reduced filling. They combine them into one phase. I like the version where it goes rapid filling and then a separate phase for reduced filling. So you definitely need to know the names. You need to know what is taking place in each phase or during each component. So during atrial contraction, for example, you're going to need to know what's happening with the EKG wave at that point. What are the AV valves doing? What are the semilunar valves doing? Generally, what's happening in that phase. What blood pressure recordings might be recorded, and then any other information. So we're not going to fill out, like for instance, the blood pressure. Not all phases are going to have a blood pressure component that we're going to talk about. So not all of them are going to have all the things. But you need to know, for example, if I were to say on the test, what are the semilunar valves doing during rapid ejection? Are they opened or are they closed? You need to know what we're talking about. You need to be able to answer that question. So, cardiac cycle. When we're talking about the cardiac cycle, this is the period of time that begins with the contraction of the atria and ends with ventricular relaxation. So it's basically the entire PQRST wave. Systole, again, is contraction that the heart undergoes while it pumps blood, also known as depolarization. This is when the chamber is contracting, causing blood to leave the chamber. Diastole, the period of relaxation. This occurs when the chambers are filling with blood. That's when they are repolarizing. They are relaxing. It is getting ready to receive blood, or it is receiving blood. Now, both atria and ventricles, the top chambers and the bottom chambers, both undergo a period of contraction and relaxation. However, when we're talking about the cardiac cycle, we're going to be specifically talking about the ventricles and what's going on with them. When you're looking at a blood pressure, you do need to understand, because we're going to be talking about blood pressure in this one, you need to understand what the numbers mean. So the top number is the systolic number. This is the higher of the two numbers, and this means this is the pressure that is in the arteries when the heart contracts. So this is during, think about it, when you've got something contracting, this is when the blood is leaving the heart under intense pressure. So this is the systolic number, the number when the heart is contracting. Now the bottom number, known as the diastolic number, this is the pressure in the arteries when the heart is relaxing. So this is the number that actually is the one doctors really are paying attention to. When your heart is relaxed, what is the pressure in millimeters of mercury? That's what the mmHg is. In millimeters of mercury when the heart is relaxed. You want this number to be low. You want your pressure in those arteries when the heart is relaxed to not be very high. If that's high, that's dangerous. So that, a lot of times they say the diastolic pressure is the one that will make you die. It's the important one. The top one, I'm not saying it's not important, but they really look at that bottom number. Just to give you an idea, if you wanted to know normal blood pressure. You're going to learn all this in nursing school, but I wanted to go ahead and just kind of put that up right there. Again, they really are watching those bottom numbers on that diastolic pressure. Okay, so now you should have your paper in front of you. We're going to go through the entire cardiac cycle. But before we start, you kind of have to know where to begin, right? We have to know what the condition of the heart is before you even start talking about the cardiac cycle. So what's going on with the heart, and then we can begin the cardiac cycle. So initially, and I've got a picture over here, and again, the pictures are on your paper as well. So you can take a look. Remember these right here, these valves, these are your atrioventricular valves. That is your bicuspid and your tricuspid valve. We're just going to collectively call them the AV valves. They're both relaxed. They're in diastole. They're in a relaxed state. They're both open. Blood is going to be flowing. You can see those big red arrows there. They're going to be flowing from the atrium directly into the ventricle. There's no pressure involved. The door is open, so the blood can easily flow from the atrium into the ventricle without anything impeding that. But as you notice, the aortic valve and the pulmonary valve, I'm trying to say semilunar and pulmonary at the same time. The semilunar valves, both of these, are closed. So what this is telling you is blood can enter the heart, but it can't leave. So you got blood coming in from the inferior vena cava, you got blood coming in from the superior vena cava, it's going into the right atrium and easily flowing into the right ventricle. And the same thing is happening on the left side of the heart. But blood is entering the ventricles, both right and left, but it can't get out. So you've got filling going on. And again, under no pressure whatsoever. So this is relaxation. Now that we kind of have that going on, you also have another page that's in your handout, and we're going to kind of be referring to this along the way. This graphically is showing you what's happening. So when you're looking at some of the terms on this, I went ahead and put them down for you here. So this AP right here, this is atrial pressure. I'm sorry, aortic pressure. So this is the pressure in the aorta. So initially, these are your phases up here, phase 1, 2, 3, 4, 5, 6, 7, which I wouldn't use those numbers. If I were studying for this, I would write the numbers of those phases down and actually have that on that sheet. I put the actual name of the phase because that makes more sense. So again, when you get into the pressure, you're following this dotted line right here. When you get into ventricular contraction, that's when the blood is going to be pushed out of the ventricles and go into the aorta. So this right here is why this is so high. And again, you're really watching that aortic pressure during relaxation and contraction. LVP is left ventricular pressure. LAP is left atrium pressure, the pressure in the atriums. And then you have LV EDV and LV ESV. You definitely need to know what those are. This is your left ventricular and diastolic volume, left ventricular and systolic volume. So we're going to be taking a look at these two terms specifically. And diastolic volume is the blood that's in the ventricle before the ventricle contracts. So it's how much blood is in there before it pushes the blood out. What's the volume? And then left ventricular and systolic volume. This is the blood in the ventricle after the ventricle contracts. And believe it or not, when the heart beats and the ventricles contract and push blood out, not all the blood is actually leaving the ventricle. It doesn't push 100% of the blood out of the ventricle. Some of it stays in the ventricle. So how much is still in that ventricle after contraction? That's what the left ventricle and systolic volume is talking about. So here, the top part of that paper is going to be pressure related, right? The middle section here is going to be your volume in the ventricles. So you can look right here in this first phase when we're fixing to be filling under no pressure, and then all of a sudden the atrium starts to contract. You can see the volume in that ventricle is at its maximum volume. And then right after contraction, right after the ventricles contract, you can see the volume in that ventricle is at its lowest. So you've got your end diastolic volume, the volume in the ventricle just before contraction, and then end systolic volume, the volume in the ventricle right after it pushes everything out. And you can see it's not at zero. You also have the corresponding parts of the EKG wave during this cardiac cycle, and you also have your heart sounds. Now, we're only going to be looking at heart sounds S1 and S2. We are not going to be worried about sounds S3 and S4. And the nice thing is it does kind of show you what's going on in that specific phase with the volume, the pressure, what's going on where the EKG is, and the sound. So remember that chart that I showed you on the very first slide where you kind of fill in that table? Well, if you take a look at each little section here, it will help you maybe fill that table in. And we're going to go over those answers too. So atrial contraction, again, I'm not going to call it phase 1. I'm just going to name it phase 1 just so you can kind of keep up with what's going on here. Atrial contraction, what's happening? This is atrial systole, which means the atrium are going to contract. Now keep in mind, just prior to this, all we had was the blood filling up into the heart, just passively filling under no pressure whatsoever. So we have a lot of blood in the atrium. Now, this is going to be the P wave, right? The atria contract. So what's happening is that blood that's in that atrium, while it was passively flowing into the ventricle, now we're going to contract the atrium and push the blood into the ventricle just to make sure we get it all in there. So this is going to be contraction of the atria. The pressure within the chamber increases, forces more blood more quickly into those ventricles. I know I'm looking at the right side. We could be doing the same with the left side, by the way. Now, the blood is being forced into the ventricles, but if you take a look at these semilunar valves over here, they're closed. So blood can enter the ventricles, but it can't leave. So this is rapid blood flow through the atrium contracting into the ventricles. At the end of this phase, take a look at where you're at right here with the left ventricular end diastolic volume. Take a look at what's going on right there. This right here is the maximum volume that's going to be in that ventricle at the end of this phase. So one of the characteristics of atrial contraction is that at the end of it, you've got max volume of blood in those ventricles. This is called end diastolic volume, also known as preload. We are loading the ventricles with blood, putting the most in there we can get. So now we're going to go to the next phase called isovolumetric contraction. When you look at isovolumetric contraction, iso means same volume. So during this phase right here, take a look at what just happened. The AV valves closed. We are trapping all the blood in the ventricles, and the ventricles are contracting. All the valves are closed. The ventricles are going to contract. This is the beginning of the QRS complex right here. You can see the QRS complex. Ventricles are contracting, but you don't have blood going anywhere. It's staying in the ventricle. So you're increasing the pressure inside the ventricle, but you're not allowing blood to leave. This is ventricular depolarization. You've got increased pressure happening because the cardiac muscle cells in the ventricles are contracting, but the volume doesn't change, which means we're not letting any blood in, we're not letting any blood out. Hence the name isovolumetric contraction. Look at the volume of blood in those ventricles. It's staying the same. So the amount of blood that in the ventricles at the beginning of this phase and at the end of this phase stayed the same. Again, no blood left the ventricles. You're just increasing pressure. Take a look right here. Left ventricular pressure. Look at that red line right there. Wow, you are increasing pressure dramatically in those ventricles. The closing of those AV valves, remember they were open in the previous one? The closing of those AV valves represents that first heart sound. That's why you've got S1 down here. So this is the first heart sound, S1. The pressure experienced in the aorta, take a look right here, that dotted line, aortic pressure, is going to be at its lowest. There's no blood in the aorta. We didn't put anything in there. So here's your aorta right here. There's no blood in there. We're not allowing blood to go in there yet. So this is going to be the lowest pressure that aorta is going to experience because there's no blood in the aorta. We haven't released blood to go in there yet. So this is going to mark the diastolic pressure on that blood pressure number. Remember, you got systolic on the top, diastolic pressure on the bottom. This is your diastolic blood pressure. It is the lowest blood pressure. Okay, now we're going into phase 3 and 4. We're going to take a look at phase 3, which is rapid ejection, because remember, we're going to split that ejection phase into rapid ejection versus reduced ejection. So we're going to really look at phase 3, rapid ejection first. Take a look at what just happened. We open the gates to those semilunar valves. So the blood from the right and left ventricles is now rushing out of the ventricle. It exceeded so much pressure, it caused those doors to open, that aortic semilunar valve and that pulmonary semilunar valve opened, and now blood is rushing into those blood vessels, into the pulmonary artery and into the aorta. And if you take a look, I already just said that, maximum outflow velocity is reached. So this is when the aorta is going to be under maximum pressure. Look what happens right here at that aortic pressure. It is maximized at the end of this rapid ejection phase right here. Look at your blood volume in the ventricle. It's leaving the ventricle. Notice it's going from end diastolic volume to end systolic volume. So all that blood that is leaving the ventricle is now entering into the aorta, causing that aortic pressure to be at its maximum right here. So this is going to be when systolic pressure is going to be indicated. Systolic pressure, keep in mind, is pressure when there's blood in the aorta under maximum pressure. And again, at the end of this, at the end of reduced ejection, all the valves, AV valves, are still going to be closed, but those aortic and pulmonary semilunar valves are going to be open. And I do want to make sure you guys know that we're getting to where we're at our lowest blood volume in those ventricles. So now let's look and see what's happening during phase 5, during isovolumetric relaxation. Iso means same, so what we're doing here is we're keeping the same amount of volume of blood in the ventricles. No blood is entering, no blood is leaving. But take a look at that pressure. We are relaxing the ventricles. All the valves are closed. Remember, we just pushed all the blood out of the ventricles. Well, most of it anyway. So whatever blood is left is going to be that left ventricular end systolic volume. So take a look. No blood. Look at that straight line right there. No blood is leaving the ventricles. This is the lowest volume of blood you're going to have. This is the end systolic volume. Now, the closing of those semilunar valves is going to represent that second heart sound. Oops, sorry. Is going to represent that second heart sound. So S2 is going to occur during this as well. So you're going to have the end systolic volume during this phase, and you're also going to have the second heart sound during this phase. I am going to make sure y'all know as well, before we kind of get into it in the next section, that the difference between the diastolic volume and the systolic volume, the difference between these two numbers is called stroke volume right here. And it's usually around 70 milliliters. So normally the heart pushes 70 milliliters of blood out with each beat. Rapid filling. This is the next phase. So what we're doing is we're opening those AV valves again. No pressure, okay? This is passive filling. Blood that was in the right atrium. Let me go back. So notice what's happening in the right and left atrium right here. We've got all the valves closed. I know we've been talking about the ventricles. We know there's no blood entering the ventricles and no blood is leaving the ventricles, right? We've got all the doors shut. But what's happening with the atrium? You still have blood coming in from the inferior and superior vena cava and from the pulmonary veins. So you've still got blood entering into the atrium. And blood is just passively entering into the atriums. So those atriums are filling with blood. So when you open that door right there, those AV valves, the blood that was in the atrium is just going to rush into the ventricle. Now, we didn't contract the atrium. We're just opening the door and letting the blood in. This is passive filling. Atrium's not contracting, but the blood that was hanging out there during the previous phase is now able to enter into the ventricle. And then the last part of that phase, reduced filling here, the ventricles at this point are about 90% full, and we haven't even contracted the atrium yet. So a lot of the blood that comes into the ventricles is actually from just passive filling. Remember, phase 1 is atrial contraction, which hasn't happened yet. So make sure you know your phases of your cardiac cycle. I do have a video here for you guys to watch if you need to understand this a little bit better. So this is about a 4-minute video, so I've put this on there for you guys. There is a cardiac cycle video quiz that is on your Moodle page for you guys to take a look at. It is for a grade, so make sure you get that done. There's, again, handouts. This YouTube explanation of the cardiac cycle may be a little bit more than what you might want to learn, but I did include it on here. So it's about 14 minutes long. It's a lengthy one, but he does a really good job going over it. So if you need to hear it again, that's a really good video for you to watch. I actually don't have any questions in this set. So that's going to conclude this particular objective.